In this video, I want to talk about the mean value theorem for the definite integral. In our next video, we're going to use this theorem to prove the fundamental theorem of calculus part 1. The mean value theorem for the definite integral says that if f is a continuous function on the finite closed interval ab, then at some point c in that interval, f of c is equal to 1 over b minus a times the integral from a to b of f of x dx. Well, I recognize this as the average value of f when f is an integrable function. That's the definition of an integrable function's definite integral. Well, our function is continuous, which means it's integrable. So what I'm saying in this theorem, or what this theorem is saying, is that if f is continuous, at some point over the interval on which it's continuous, there has to be a function value equal to its average value. Well, we can think about that as saying this. If I draw a continuous function over a finite closed interval, I know it has a minimum and a maximum value. That's what the extreme value theorem says. Right? There's a absolute minimum and an absolute maximum because this function is continuous over a finite closed interval. The average value of the function has to be somewhere between those two values. And that makes sense, and it's also a consequence of the min-max inequality. But I can imagine that the average value might be something like this, right? That's that mean value of the function, the average value. And I can actually see in my diagram 3 places where an f of c, the y value, is equal to that average value. There's a nice rigorous proof of this using the min-max inequality in your textbook, but really we can think of it as a consequence of the intermediate value theorem. The average value is between the min and the max, so my function has to cross that value at some point.